An exponential function is the function of the form f of x equals a to the power x, where a is a positive number that is different than 1. As you can see here, the input becomes the power of the exponent whose base is a. The domain of such function is the set of all real numbers. So that means that in the exponent place we can put any real number. So the question is how such exponents are defined. We know how the exponents are defined when the powers are integers or rational numbers, but we don't know how the powers are defined when the number is irrational. So let's recall quickly how we build the exponents on an example. On the left side you have the formal definitions of the exponents. So what is 2 to the power third? 2 to the power third is the product of the base as many times as is indicated by the exponent, and therefore it is 8. When the exponent is negative integer, such exponent is defined as reciprocal of the exponent with the absolute value of the integer, and therefore in this case is going to be 1 over 32. When the exponent is of the form 1 over positive integer, then this exponent is defined as the radical of, in this case, 4th degree of 16. And fourth radical of 16 is such a positive number that when raised to the 4th power is going to give us 16, and therefore this number is 2. Now, what if the exponent is a rational number? So it means it is a quotient of two integers. In this case, we define this exponent as the radical of the 3rd degree of the base, and we raise it to the power that appears in the numerator of the exponent, and therefore in our case it's going to be 2 to the negative 2, which is 1/4. One thing worth noticing here is that even though sometimes the powers are negative in this example, the answer is never negative. So now let's address the question of raising number a to irrational number. For example, how would we define 2 to the power pi? Now let's recall that the pi is an irrational number that has infinite decimal expansion, with a couple of numbers that we have written. That decimal expansion will never end and will never repeat. So how do we define 2 to the pi? Well, first we notice that because the pi is that irrational number that will never repeat or never end, we can form a sequence of numbers, starting, for example, with 3 and going with the next digit of the pi 3.1, then next 2 digits, then next 3 digits, and so on. So every time I form the number here, I will be adding one more digit to previous number. So if we continue this forever, then the values that I have here in this column are going to approach number pi. Now, if I compute the values of the power 2 to any x in that column, that values are well defined because the number x are rational numbers. They have the finite expansion, decimal expansion, so that means they are rational numbers. So I can form 2 to the power 3, that's going to be 8. I can form 2 to the power 3.1, which is really 2 to the power 31 over 10, and therefore it is well defined. I can form 2 to the power 3.14 because this is 2 to the power 314 over 100, and so on. And what it has been noticed, or it has been shown in more advanced math courses, that these numbers approach certain number that is has the decimal expansion 8.8249 and so on. And this number, therefore, is called, because it's the only number, this is the expansion of the number 2 to the power pi. So in that way, we can define 2 to any irrational number, because again, it can be shown that any irrational number is a limiting value of similar sequences we have in the table of rational numbers.